Hi everyone, I'm from Time4Maths here today. We're going to go through the last question from the CSSA Advanced Paper 2024. We've got one circle and a line. D is a constant. The circle and the line intersecting each other exactly at 2 points. If we quickly visualize the scenario here, when I've got a circle and the line, we've got 3 different scenarios. That line ought to intersect at 2 points, or to intersect at 1 point, and we call it tangent, obviously, or there's no intersection at all between these two, between the circle and the actual line. If we quickly go over this one from an algebra perspective, I'm able to see this one as 2 solutions, 1 solution, and no solution. And this should remind us quickly by the discriminant, because the idea behind discriminant in quadratic, all right, no solution, 1 solution, or 2 solutions. So somehow, in this question, we're going to take advantage of the discriminant. And when we get any question about intersection, it's always the case of y equals y. So what we're going to do, we're going to sub that y in. It's like similar to simultaneous equation. You sub it in. And what we're going to get in this scenario here, x minus 1 squared plus x plus d minus 3 to the power of 2 equals 9. Normal algebra from here, we're going to get x squared minus 2x plus 1. We're going to expand this one. That's the same as a perfect square, but we're dealing with 3 terms. So the first one square and so on. Then 2 multiplying the first 2 terms, 2 multiplying the last 2 terms, and 2 multiplying first with the last term. So what we're going to get, x squared plus d squared plus 9. And we're going to get plus 2xd, first 2, last 2, minus 6d, first and last, and you multiply by 2, you get minus 6x equals 9. We're going to collect like terms. So x squared and x squared, we're going to get 2x squared. All right. And here I'm going to take x straight away as a factor so I can get b. All right, for like b squared minus 4ac when I apply the discriminant in the next step. Minus 2, all right, so I'm going to highlight them again. Minus 2 and minus 6x is going to give me minus 8. And you've got here plus what, 2d. All right, and what's left, which is 1, 9, that's going to give me 10. And I've got minus 6d and d squared. So that's 10, all right, plus or minus 6d plus what, d squared equals 9. If I move that 9 to the other side, it becomes what, 1 and equals to 0, all right? Or you can simply cross 9 and 9 and write whatever it's left. So the discriminant in this scenario here, all right, which is b squared minus 4ac. What we're going to get, that's b here, minus 8 plus 2d squared. And minus 4 times 2 is 8, because a is 2. And that's c, 1 minus 6d plus what, d squared. We're going to expand normal algebra again. That's 64 minus 32d and plus 4d squared minus 8 plus 48d and minus 8d squared. All right, collecting like terms, so I'm just going to write it here. All right, 4d and minus 8d is going to give me minus 4d squared. So let's just cross them so we don't get confused. And 48 and minus 32 is going to give me plus 16d. All right, and we're going to cross these two. And what's left, 64 minus 8, and it's going to give me plus 56. Keep in mind, because as I said, I've got 2 solutions, as I mentioned before. So we know like the discriminant has to be positive in order to get 2 solutions. We notice like I've got 4 as a common factor. What I'm going to do, I'm going to divide by minus 4, and we'll flip the inequality. So we're going to get here, in this scenario here, we're going to get d squared minus 4d, and this one, it turns to be minus what, 14. All right, and that's less than 0 here. We're gonna, we should pay attention to this again in the quadratic. Graphically, it's parabola concave up, all right? And I've got the 2 values here with the x-intercept. We're gonna apply it very soon, so I'm gonna apply the quadratic formula to find these 2 values. But because the quadratic has to be less than 0, what does this mean? D has to exist between these 2 values. All right, So in order to apply the quadratic formula, it's minus b plus minus b squared, which is 16, minus 4ac, sorry, that's 16, not 16 squared. It's 4 to the power of 3, 16. And minus 4ac, we're going to get what? Plus 56 over 2a. When we collect like terms here, anyways, that's straightforward. 72, we are able to see it as 36 times 2. 36, you take it outside, it becomes 6 root 2 on 2. And when you divide everything by 2 here, you get 2 plus minus what? 3 root 2. Obviously, this one has to be the smallest value, which is with a negative. So that's 2 minus 3 root 2. All right, and this one here, 2 plus 3 root 2. And d has to be between these two values, and that's exactly what they ask. We finished question A, and before we move to question B, I've just covered what I want from question A, so in order to solve question B. Question B is they're telling us the distance between the 2 points of intersection between the actual line and the circle. They have a distance of 2 root 3. And the question asking us by determining the coordinates of A and B, we need to find a possible solution, all right, for D. If we visualize the actual scenario here again, I've got a circle, the line when it's intersecting the circle, all right, at 2 points. That distance between the 2 points, it's 2 root 3. All right. Other than this, we've got this solution here, and we are able to get another solution if the line it's under, such as A and B here, and we're going to again get what? 2 root 3. These are only possible solutions, could be above or below the center, and both of them with what? 2 root 3. So this tells us directly, like we're going to get 2 possible values of D. However, the question asking us just to get one of them. All right. Or if I quickly go back, if I've got the intersection between 2 different graphs, that's what we've done in question A. The additional given data here in question B, they gave us what? The distance. When they gave us the distance, we know like they're only like, because obviously we're dealing with coordinates here, the quickest way is to apply the distance formula. So in this scenario here, we're going to get what? The distance formula says x2 minus x1 plus y2 minus y1 to the power of 2 equals what? 2 root 3. However, instead of 2 and 1, I've got point A and B. So let's quickly replace them. And you need to keep in mind, all right, they are given equation. So in order to get the y value, all right, if you've got the x value, you sub it in and you are able to get what? The y value. So what I'm going to do here, I'm going to represent, instead of saying xa, xb, and so on, I'm going to put the point A, all right, just easier to write. I'm going to put it as a coordinate A. And this one, if I sub it in, I'm going to get what? A plus D. I'm going to do the same thing for B. I'm going to call it B for the x coordinates, and I'm going to get B plus D when you sub the coordinate into the equation. Applying the quadratic formula here, sorry, I should say the distance formula. When you apply the distance formula, you notice like you're going to get B minus A to the power of 2 plus, let's do it step by step for now. All right, you've got B plus D minus the y coordinates of A. The y coordinates of A, all right, it's going to turn to be minus A minus D to the power of 2. All right, minus D and D, they cancel each other, and you notice you get exactly what? The same value. So you're going to get inside the square root 2B minus A to the power of 2, and that's equals to 2 root 3. If we square both sides, all right, we're going to get 2b minus a to the power of 2, and that's 4 times 3 is going to give me 12. So long story short, we're going to get b minus a to the power of 2 equals what? 6, all right? And when we square root it, b minus a, we're going to get what? Root 6. All right. So that's technically what we're going to get here. So keep in mind that b and a, as I mentioned before, it is the coordinates of point A and the coordinates of point B. Keep in mind that the x coordinates, it's at the same time the solution from this quadratic equation. Because when this came, remember, from question A, when we said y equals y, it means the intersection between the actual circle and the actual line. So what we need to do here, we need to find the x solutions, the two solutions from the quadratic. but I noticed like I need to minus the two solutions from each other. All right. According to the quadratic formula tells us that two solutions minus b, all right, plus minus square root b minus what, 4ac on 2a. Just keep in mind that b and a are not related to this one, all right? So I used a and b here just to refer to the x-coordinates and b as the x-coordinates, where here a, b, and c are the coefficient of x squared, x, and c. So no one gets confused. All right. We need to minus the two solution because that's technically x2, and this is x1 from the actual quadratic equation. All right, so which is the two solutions. When we minus them from each other, instead of getting each one of them, if you minus them from each other here, you notice like you're going to get minus b. I'm going to write this one as plus root of the discriminant over 2a. That's technically the first solution, x1. All right, and x2 is going to be with negative, all right, 2a. When you minus them from each other, what you're going to notice, because I've got the same denominator, so let's write it x2 minus x1. So this one minus that, all right? So if you follow me here, we're going to get minus b minus root of the discriminant on 2a minus this one here, all right, because it's the same denominator, all right? Negative and negative, this one is going to turn to positive, and this one going to turn to negative. Do you agree? So we're going to get this solution. However, because distance is always positive, we can't get like a negative, so I should minus the biggest from the smallest. If anyone asking how do you know which one is the biggest, obviously because of the plus, this is the biggest. So I should do like this one minus that, not the other way around. So I'm going to write minus b plus root of the discriminant minus this one, then both of them will turn to positive. B and minus b, they cancel each other, and 2 root discriminant on 2a, we're going to get root discriminant on a only, and this equals what? To root 6. All right, I'm going to quickly solve it here. If we square both sides, we're going to get discriminant equals to 6a squared, and you notice like it becomes straightforward from here. That's the discriminant, and a equals what? To 2. All right, so what we're going to get minus 4d squared plus 16d, all right, plus 56 equals to 6 times 2 to the power of 2, which is 4, is going to give me 24. I'm going to move everything to one side, all right? I'm going to move everything to the left-hand side just to turn the coefficient of d squared to positive. I'm going to get 4d squared minus 16d, and 24 minus 56, we get 32. Minus 32 equals 0 here. All right, just like a normal or before, I noticed like we are able to simplify by 4 just to make it easier, and that's minus 8 equals 0. Then we're going to get minus b, solving normal quadratic equation, plus minus, all right, b squared, which is 16 minus 4ac, so that's plus 32 on 2, and that's 4 plus minus, that's going to give me 48. We know 48 is 16 times 3. Let me put over 2 here. That's 16 times 3. That 6 is going to go to the other side, outside the square roots, and we'll get plus minus 6 root 2 on 2. And what we're going to get here, plus minus, if we simplify by 2, 3 root 2. And you notice this is the 2 solution of D. If you have any question, please leave your comments, and we'll try to answer your question. Thank you very much for watching, and if you like our channel, please subscribe, and we'll see you next time in our next video. Thank you.